In the instrumentation lab, we have a number of Allen Bradley Micrologix 1100 PLCs equipped with analog input-output channels, enabling them to become full-fledged loop controllers, PID loop controllers. Right now, a team is using this PLC to control an air pressure process over here. I wanted to describe briefly how we access these controllers through the remote network and how we're able to change some of the important parameters inside to use them as a loop controller in your process. So, we're going to go over here to one of our computers that's equipped with the proper Allen Bradley software. So first thing we'll do is come over here and we're going to check and make sure that our communications are properly configured. So down in the corner you should see a small icon for the RS Links utility. It's in the system tray here running as a background task. We'll open that up and we'll go to communications and we'll look at RS Who. If everything's set up properly, we should see the driver for Ethernet communications right here. We can expand that, and then we can see two PLCs on our network. Each one has an IP address. .7.8 is the first one, and .7.9 is the second one. We have numbered these and the IP addresses according to the junction box they're in. So we just looked at the PLC in junction box 8, and that is the 169.254.7.8 you see right there. There's also a junction box 9 that has its own PLC, and later we're going to get the other Micrologix PLCs on the network, so we'll have more PLCs listed here. So this step right here is simply verified that we're up and running with our communications. So next we go to the actual program itself for looking at the software in the PLC. That is RS Logix Micro English. We're going to start that up. The program has been designed in the PLC so that when you use this to configure your controller, you will not actually have to save or download a new copy of the program to the PLC. You'll simply be making online parameter changes, which makes it very flexible and convenient. So I'm going to go up here to comms, right there, and I want to go who active go online. I simply want to go online with one of my PLCs. So right now I'm going to take a look at the PLCs on that driver on the network, and I'm going to go with the PLC in junction box number 8, that one right there. So I'll click that so it's highlighted in color. I'll go to OK. Now it's going to want to go online and ask me, do I want to use a file on the PC right here, or do I want to just create a new file? And I definitely want to create a new file. So I click on that, and here's my running PLC program. I'm in remote run mode right here, and you can see a few instructions. Now most of the program is hidden in subroutines. All we see here is the main program page. And on this main page we have a subroutine jump instruction, a scale with parameters instruction, we have a PID instruction, and that's for the first PID loop, loop 0. Then we've got another jump to subroutine, another scale parameter, and another PID instruction. That's for the second loop in that same PLC. So each PLC can actually support 2 PID control loops. So let's pretend we're going to work on loop number 0. The scale of parameters right here takes the raw count value from our analog input card and it scales it to whatever engineering units we desire. This particular team has scaled theirs to output 0 to 10, representing 0 to 10 psi of pressure in their process. The raw count values here, the 3120 or the 15600, that comes from the A to D card, and 3120 is nominally what you should get with 4 milliamps of current, and 15,600 is nominally what you get for 20 milliamps of current. We use a scale instruction here to scale those raw count values into some sort of engineering units that will make more sense on an operator's display. And notice, in both these cases, we have those low and high range parameters stored in floating point number registers, so F87 and F86. We come over here to the floating point files, and here we have F86 and F87. So F86 is where it stores the upper range value, F87 is where it stores the lower range value. So let's suppose we wanted this to express the process variable in terms of percent instead of PSI. I could simply change that to 100, representing 100%. There we go, 100. I hit the enter button, and as soon as I do that, you see that number value updated there, and lo and behold, we're going to be scaled in percent here instead of PSI. So this is very convenient. We've made a change here. It's an online parameter change. We did not have to save the program. We did not have to download to the PLC. We simply made an online parameter change, hit the enter key, and that is it. So I'm going to put back to 10, where it was before. Now, Another thing you may need to change when setting up your loop for your process is some of the parameters inside the PID instructions. So we'll click on the setup screen here, and one of those parameters you'll be interested in is the control mode. Therefore, this is going to be controlling whether the PID instruction does direct or reverse action. Right now, the way it is, error equals setPoint minus PV, this is configured for reverse action. As the PV value rises, the error will go down, driving the output down. That's by definition reverse action. If we want to change this to direct action, simply click that, drag down PV minus setPoint. Well, now that's direct acting. If I were to hit the Enter key, this would again save that online parameter, and this would lo and behold be a direct acting controller. I do not have to save the program, I do not have to download to the PLC, I simply make my selection, hit the Enter key, and that is it. When I'm done making any other changes here I'd like, I simply exit out of the program and I'm done with it entirely. A note here, the gain, the integral, and derivative values, we currently have those set up, so those values are coming from the HMI operator interface, the human-machine interface panel. If I try to change any of these, it won't let me because the panel simply overwrites the values. So when it comes to PID tuning, those changes are done from the graphical operator display panel elsewhere in the lab. But here, on our RS Logix Micro program, we're going to set up other things that operators normally wouldn't adjust, like control mode, or perhaps output limits or set point limits. And again, you simply enter the number, hit the Enter key, that's now saved in the PLC's RAM memory, and you are done. At that point, you simply come up here, X out of the program, save changes. No, we do not want to save changes because you've made the changes online. No need to save on the PC, no need to do a download. And that's about all there is to it, to configuring the basic parameters for one of these PID loops in the MicroLogix 1100 controllers.